In this video, we're going to prove the quotient, or excuse me, we're going to prove the chain rule. In other words, we're going to prove that if h of x is equal to f of g of x, then h prime of x will be equal to f prime of g of x times g prime of x. Now, the way we'll begin that proof is as written here in the second line. Whoops. As written here in the second line, we're just going to begin by stating the definition of the derivative of f of g of x. So obviously it's the limit as h goes to 0 of f of g of x plus h minus f of g of x all over h. Okay, a lot of proofs begin with the definition, so does this one. Now what we're going to do next is we're going to multiply the entire limit I just described, the one I just circled. We're going to multiply it by g of x plus h minus g of x over g of x plus h minus g of x. In other words, we're multiplying by 1. And we're going to assume that g of x plus h minus g of x does not equal 0. In other words, we'll assume that we're not talking about a straight horizontal line where the y coordinates are identical. Okay? And so moving on then, what we're going to do next is we're going to switch the order of the denominators. So we're going to move the second denominator under the first fraction and the first denominator under the second one. Okay? And, we're allowed to do that. We're just multiplying fractions. And we're also going to, if you notice, we're going to, instead of talking about the limit of this whole expression, we're going to talk about the limit as h goes to 0 of this first expression times the limit as h goes to 0 of the second expression after we switch the denominators. And so that's what we've done in the next line. Okay? We, so to speak, distributed the limit notation and we switched these two denominators. We switched these two denominators right there. Okay, so now this is where the proof gets pretty interesting. H is representing the horizontal distance between 2 points. Well, g of x plus h minus g of x is representing the vertical distance between 2 points. Now, as we can assume that our curve is continuous over this interval that we're talking about, so as the horizontal distance between 2 points on a continuous curve gets infinitely close to 0, the vertical distance between the 2 points on that curve will also get infinitely close to 0. Okay, so as h is going to 0, we know this denominator is going to 0, but we can also say this denominator is going to 0 as well. Okay, so that's what we're saying in this line. As h goes to 0, the expression g of x plus h minus g of x, which is in red, also goes to 0. In other words, the horizontal distance between the 2 points gets infinitely small, so does the vertical distance between the 2 points get infinitely small. Okay, so we're going to let that value, this g of x plus h minus g of x that's in red right there, we're going to give it its own variable. We're going to call it k. Okay, now what's going to happen next is we're going to say that as h is getting infinitely small, here's my h right there, as that's getting infinitely small for the reasons we discussed earlier, so is the vertical distance between the 2 points. In other words, so is k. And as k is getting infinitely small, so is h. So what I can actually do is I can say k is going to 0. Not just h is going to 0, I can say k is going to 0. And believe it or not, since h and k are both going to 0, I can switch that h I'm pointing at right now also with a k. So we do that in the next line. And we have the limit as k goes to 0 of f of g of x plus k minus f of g of x all over k. And we're multiplying that by the limit as h goes to 0 of g of x plus h minus g of x all over h. Now, if you think about it, this first expression, that's just the derivative of f of g of x. Now, granted, normally we say h goes to 0, we replace that with a k, but it's just the derivative of f of g of x. And the second one, that's just the derivative of g of x. Now, the way we write derivative of f of g of x is we write it as f prime g of x. And so ultimately what we're doing is we're just multiplying this quantity with that quantity. Okay, and so we get that the derivative of f of g of x with respect to x is f prime g of x times g prime of x.